Hello everyone, welcome back to our channel. Today we're going to work through this problem and let's first read the problem statement. The volume of a cylinder V can be expressed as V equals pi r squared L, where r is the radius and L is the length. Find the uncertainty in the calculated volume of a cylinder at the 95 confidence interval UV, given radius and length measurements. So r equals 50 plus or minus 0.1 centimeters and L equals 6 plus or minus 0.1 centimeters. So first we have to figure out what equation to use, and we will look at our equation sheet. So basically, this is the equation that we want to use over here. This is the error. And we want to find it at the 95 confidence interval. So let's use this formula. So over here, like we have the equation we want to use, and basically, so here instead of x and y, we have r and L, and that's what we're going to differentiate. So we first have to find the partial, and this is the one we want to find the uncertainty. And so we'll find the partial derivative of f x y, or over here it's actually going to be VRL, so VRL, but I'm just going to write it in terms of V so that it'll be in a simpler form. So dV dx. Oh, sorry, I keep saying x is dV dr, and this is equal to 2 pi RL. And let's find partial derivative with respect to L. So this is equal to pi r squared. And we evaluate it at x naught or y naught, which in this case is going to be I believe the 5 and 6. Yes, it is indeed the 5 and 6. And basically, we have also UR and UL. So UR is the uncertainty due to the radius measurements, which is going to be 0.1 centimeters, and UL is the uncertainty due to the length measurements, which is 0.1. And UF is going to be equal to the square root of the partial derivative. So it's going to be 2 pi RL times UX. So 2 pi, let's substitute in R and L. So R is equal to 5, as we see over here. So 5 times R, which is times L, which is 6, and times the UR, which is 0.1, and then plus, and all this squared plus uh dV dy. So it's pi r squared, so pi times 5 squared uh times uy, so or ul over here, which is 0.1. And calculating this, we get that uf is equal to, so this one is equal to 20.4 centimeters squared. So that is the uncertainty, and I'm be posting these slides. I hope this was helpful for you guys. And actually, before we part, I want to understand this a little better and help you guys understand it a little better. So the equation in the image is this, and this is the uncertainty propagation formula for a function of two variables. So fxy is a function of two variables, and uf is the uncertainty in the value of the function f at the point x naught, 0 naught, well, x naught, y naught. UXY, UY is the uncertainties in x and y respectively, and partial derivative of f with respect to x and y are those. So yes. Okay, see you guys next time.